Hi, in this video I'm going to quickly show how to program the Springbot using a scratch-like programming called MicroBlocks. I'm running the app, and when I'm running the app I connect to the Springbot up here by simply clicking on the USB connection that it's connected to here. Using the app you can only connect to it using USB. Using the browser, you can use either Bluetooth or USB. So just to get started here, we do a simple thing here. We say when the button here on the back, this button here is pressed, we want to turn a LED on. So we say set LED, and we maybe also just want to say 1, 2, 3. So I click run up here, and now it's running. Then I click on the button and you can see the LED turns on, and here on the screen it's a little speech bubble say 1, 2, 3. So I click run again, it turns off the LED because it starts over, and I simply just click and it turns on. Let's go a little bit further here and then use a library. So the first library we're just gonna do is we're gonna take a NeoPixel. So there's 2 LEDs on that. There's a red LED, and then there's a color LED here that's called NeoPixel. So if I say open this one here, then I have to attach this thing here. So let's start with this. Let's just get rid of that. And then we have to attach the NeoPixel here. And we have to tell how many pixels we have. We have 1. This will work if you have a string of NeoPixel also, but what pin is connected to. So here I want to show you the first website, and that is this GitHub where we have documented the Springbot. So there is a green one with LED only, and there is the gold one, the one I have here, that have a LED screen. The gold also have NFC. I'll come back to that in a later video. And it has a lot of sensors on. Down here you can see how the different pins has been connected. And here you can see that pin 39 is connected to a NeoPixel. If I then go up here and say 39, then I have now programmed this thing here to say it has to use that pin for NeoPixel. We're going to put a loop in here. We're going to say set all NeoPixel. There's only one, but that's fine. And we're going to set a random color. And then we're going to go in and say wait a little bit in between. Let's say 100 milliseconds. And we're going to run this. And you can see the LED is then changing colors on the back here. So let's start using the front. Let's try another example. So now we're going to take a library here. We take the graphics and we say OLED graphics. So what we do is that when we start, we have to initialize the display with the 2 first commands here. The one initialized I2C, the other connects to the OLED using I2C. Then we want to have a loop, and we want to give it a little pause at the end of the loop. And let's just start with writing a text. So let's write I'm going to demonstrate if I, for example, wrote the time. So I'm writing a little bit, let's say 5 pixels in, 10 pixels down, and I scale it up here to 3. So I run that, and it will, of course, just demonstrate the clock here. Now, let's take combine that with another library. In this case here, we're going to take the onboard temperature and humidity sensor. Again, if we go to the documentation here, we can see up here that it says it has a AHT20 temperature and humidity sensor. It sits on a default address, but it's there. So let's go back to our program. So we can go in here under library, and we can go in and say sensing, and then there's all kind of different sensors here. So let's go down to temperature humidity. There's the AHT20, say open, and then we can actually get the temperature. So I can just drag the temperature in here instead, and then I can run it, and you can see it says it's 30 degrees. And now, just to demonstrate, I can actually put my finger underneath on the temperature sensor so I can get it to increase. Probably not a lot since it's already hot enough, but there we got it up in temperature, and it will drop again when I take my finger off. We also have an analog sensor, a light sensor. So what we want to do now is that we want to read from an input pin that's analog. So we say read analog pin here. We put that up instead of that, but we have to read from the right pin. We go back into our documentation, and we can see down here that we have a phototransistor sitting on pin number 7. So we have to put in pin number 7 here, and we run it, and it shows a lower number. As we lift it, we get more light underneath. If you go to microblocks.fun, so if you go to get started, you can see here that on the browser, you can run it on Chrome and Edge. You can run on Chromebook, on Windows, Mac OS, and Linux. And there is instruction how to set it up when you want to run it on the different versions here. If I go to download, it automatically figure out that I'm running on a Mac OS, so I can download, and you can see that today it's the 15th, and 3 days ago they released the latest version of the software. So it's a continuous developing software, and they actually support a lot of different platforms. So down here you can see the pre-compiled virtual machine. You can use this thing here for the microbit, the BBC microbit. You can use it on a Raspberry Pi Pico. There is the M5 stack, which is also there. And then, of course, the ESP32, which we're using here. And the old expressive ESP8266 also work with this thing. Has a lot of different single board computer that uses this thing here. So if one go down the line with MicroBlocks, you're still able to run it on a number of other single board computers, like the Springbots.